I'm Dr. Upasana. I am representing Genes to Me today. And what I'm going to be talking about today is the management or the need of rapid diagnostics when it comes to sepsis detection. So I'm sure sepsis is neither a new term for anybody or nor something that you must have heard for the first time. It's something that we deal with globally. I'm going to talk about a few statistics that we have to deal with. What is the relevance of this diagnostics and what exactly is the innovation that I'm talking about today when it comes to the management of sepsis, especially in the field of diagnostics, which is really relevant when it comes to a condition like sepsis. So with that, and of course, one another term that you see over here highlighted apart from sepsis is a point-of-care device. So what we have tried to innovate is the diagnosis of sepsis, not just on a point of care, but also in a very, very rapid way. That too, directly from blood, which might sound innovative to a few of you who might be aware what is the traditional method, right? So, of course, commercials first. I'm going to be talking about the company that I'm representing, Genes to Me. So we are a company which incepted in the year 2016. We are primarily manufacturers in the field of molecular diagnostics. That's where our forte comes into play. And point of care is one of the four major segments that we deal with in terms of manufacturing solutions for. And of course, I'm going to be only emphasizing on point of care today, that too in the management of sepsis alone. But we do have solutions catering to other categories like RT-PCR and NGS-based solutions and extraction-based solutions. But yeah, so that's mostly about what Genes to Me does. And we are based in India, as might be very evident. This is our global presence. We work through a distributor model partnership way where we are currently present in about 65 plus countries through a very, very strong network of supporters and distributors. And I'm not sure how many of you might have visited us at the booth yesterday or today. This is a small glimpse of where all the action happens back in India. So this is our manufacturing facility. It is located in the outskirts of the national capital region of the country, New Delhi. So this is exactly where we innovate. We manufacture all of our solutions in-house, be it in point of care, RT-PCR, or the NGS-based segments. And these are some of the feathers in our cap, mentioning some of the major customers globally, all across Europe, Middle East, US, Asia, etc. And with that, I'm now going to delve deeper into the solution and the innovation that I'm actually going to be talking about today. So sepsis, as we all might be aware, is a very strong immune system's inflammatory response, which is a response to infections caused by various protozoa, fungi, bacteria, and it can be excessively fatal if not managed timely, if not diagnosed timely. So early diagnosis and timely treatment are the two key parameters to define proper management of sepsis before it proves fatal for anybody. And as the statistics very, very clearly vocalize this, that this is one of the most leading causes of death worldwide, accounting for 20% of the global deaths, which again worsens if it is a low or a middle income country, which actually highlights the need that actually I'm going to talk about today. So again, just for maybe few of you who might not be aware, the gold standard or the traditional method to generally detect sepsis is blood culture method, which is going to take about 36 to 48 hours in general, where you need to actually, grow the cultures, bacteria, etc. And they all have different growth requirements. So it's like a panel of various bacteria, fungi, protozoans that could cause it. And that is why each one of them would need a different culture condition. So typically it takes about 36 to 48 hours of culture, post which you can actually detect which sepsis organism. And 48 hours, when speaking about a sepsis-based infection, could be really critical for a patient. So what exactly we have tried to do over here is that we have tried to revolutionize this diagnostic space through a very rapid culture-free method of pathogen detection for sepsis, wherein you do not need to culture your blood. You simply can collect whole blood and you can go directly to the point-of-care device for detection. I'm going to be actually speaking about the technology first, which we have termed as direct blood, apparent enough that it can be done directly from blood, so we have called it direct blood. I'm going to be talking about the technology first and going to the machine or the instrument that you can actually even see in-house at our booth. I'm going to give you the information of our booth as well later. So when I talk about this technology, it's very, very easy. As I said, you go directly from collecting your blood and right onto the machine, but there are few steps of very basic pre-treatment that go into it. So these are just some of the features to highlight that it is a scalable design technology. So it is suitable for a high throughput system like a 96 well also. But why am I talking about a point of care today is because it is much more rapid. It's much more accessible in a smaller OPD clinic or at the point of care for the patient. It is based on the magnetic bead-based recovery system. I'm again going to be talking about the system soon. We have made sure that it has enhanced purity, because what we effectively do in the pre-treatment steps is to remove the host DNA as well as at the same time enrich the pathogen through this technology. And again, just a few things like it is directly the use of the sample. You do not need a pre-culture, and it efficiently captures both the cell-free as well as the intracellular pathogen. How does it do so? I'm going to come to quickly that. So this is the sepsis kit that we are offering and what all it covers. So it's a 4-tube assay, and it covers 19 different organisms when it comes to the detection of sepsis alone. I'm not going to go into the details of it, but just to highlight, it includes a lot of gram-negative and gram-positive bacteria, some of the fungi, candidas, all of those are all included in the kit itself. And when talking about the technology, when I talk about putting it onto the system, which helps you do directly from sample to result, there are just a few steps of pre-treatment, which is technically where you actually divide the intracellular and the extracellular pathogens by a simple spin centrifuge. So what you do is you pellet down the intracellular part, and then you separate out the supernatant, which actually has all your extracellular free pathogens. And to the intracellular ones, you actually lyse them, followed by treating them with some patho-enrichment buffers, which is again our patented technology that we have developed. So that is called the dual phase pathogen enrichment phase, wherein we are actually lysing and taking out the pathogens out of the cells, as well as enriching them to be able to now, mix the two, which is your supernatant A from the first step, which was all your extracellular pathogens. Now the intracellular release pathogens, we mix the two of them, and then we just use 200 microliter of this sample to now put it onto the device, which I'm going to be talking about in the next slide. The device actually is made in a certain way to always accept 200 microliter of standard sample. So that's what we have defined it for. This is again some of the same things that I just mentioned. I've just actually tried to highlight the materials required for a few of those ones who are, the technical ones who might be needing this information. And now talking actually about the hero, the instrument called OnePCR. So it's a sample in result out device, which is compatible for a single sample at once and able to detect up to 20 targets in that sample. How does it exactly do so is because the device itself is based on a 5-channel fluorescence-based detection chemistry, wherein it has room for 4 PCR tubes, which means 5 targets in a single tube, and you have room for 4, making it up to 20 target detection. And when I talk about the sepsis detection per se, we have maximized the efficiency of the system by using 19 pathogen detection in the same assay, again a 4-tube assay, as I said. And to make it highly reliable, the results to be highly reliable, we have every maybe I could go back to the previous slide to show you. If you can see here, each of these tubes is also present with an internal control, RNase-P in this case, which makes the results highly reliable once you have an internal control, amplified at the same time. Having said that, coming back to the instrument, it's an automated liquid handler which helps you do right from sample to result, because it handles extraction to amplification to result detection all inside the machine. So it has, a liquid handler to be able to first, it's a magnetic bead-based extraction. Once those extraction is done, the sample is sent to the PCR for amplification. Upon amplification of these 19 targets for sepsis, the inbuilt software helps you do, a report generation. And I'm going to show you how the report also looks like in a few slides to come. So again, some of the features, but what is very interesting is, apart from, of course, I should have highlighted this a little later, that apart from sepsis, we have 50 plus assays that are compatible with it, but just sticking to sepsis for now and the workflow. The workflow is as simple as you have a pre-filled cartridge. For example, for sepsis, you have a barcode reader integrated with the device. We have the barcode scanner to scan that. So once we scan, it is automatically going to select the protocol for sepsis, which is pre-built in the device, followed by which you just open the seal pack of the cartridge, and then you load your sample and ready to run, and it is going to give you an automated report. I also have a short video to show you how exactly is this done. So these are the pre-filled cartridges, how they look like. It's cartridge 1, cartridge 2. You simply scan the cartridge in the barcode reader for the machine. after which you open the seal and you add 200 microliters of the sample right onto the device. This is the PCR tube, so it can be up to 4 tubes. In the case of sepsis, for example, you load it, and finally, once you load the cartridge too as well, you just close the door and you click on the run, and finally you will be able to have an automated report exactly looking like this, wherein you have comprehensive results encompassing CT values for every target, along with positive, negative reporting for each target, and also the amplification graph. So for a point of care, it's one of the most comprehensive information that you can gather for a point of care device of this kind. Of course, we are asked a lot of these questions that, okay, it is a single sample device, so how can I scale it up? Yes, we do have that capacity too, wherein you can integrate multiple devices and actually can control it with with a single tablet. So what we can do is we can integrate 1 to 4 to even 8 different units of this kind together, control it with a single tablet, and actually increase the throughput capacity of the device itself. And when I say it's a point of care, it actually is a true point of care. You do not need a specific lab environment to be able to run it. We have actually ourselves checked it at various sites, be it the remote areas, field camps, airports, pharmacies, OPTs, etc., just to name a few of these remote areas. Talking about the results and the reliability that we have seen so far, it's very, very corroborative with the blood culture method, which is today the gold standard used and accepted globally. But what we have seen so far, that it is showing more promising results than your traditional blood culture. I would like to highlight K pneumonia, for example, here. Any of you working on sepsis might be aware K pneumonia is one of the fastidious growth requirement bacteria, and that is why we did not see the K pneumonia present in our blood culture. However, when we checked the same sample with direct blood technology, we actually could see very, very reliable CT values in the range of 24, which is highly acceptable. ICs were all in place. So in fact, what we have been seeing is that we have been seeing much better results than even blood culture methods. And to say the least, it is definitely corroborative for the other pathogens. This is just some of the summary for the data that we have found so far, that it can detect some of the pathogens like K pneumonia, which are negative in the blood culture. Then it can effectively detect a range of pathogens, as easy to grow as E. coli and as difficult to grow as Pseudomonas aeruginosa, for example. And you can also cover detection of fungal pathogens that also we have seen very corroborative in our results. And of course, blood culture has certain limitations, like it often misses pathogens. Direct blood values, some of the lower CT values indicate a rapid and sensitive way to detect these pathogens, and culture methods can sometimes lead to false negatives. So we surpass all of these problems in direct blood technology. We in fact have some of our instruments being tested and validated at a few sites in Vienna itself as well. This is just a brief glimpse of where all we showcased recently at Vienna, and we have these sites who are already validating our system with this technology. Apart from sepsis, there's something else that we have also tried to detect using, again, the direct blood technology is AMR, antimicrobial resistance, another technique which needs you to grow the bacteria for 48 hours. Again, we have tried to minimize the timing. We have found, again, very corroborative results here too. It's a very, very comprehensive test in itself. And apart from that, this is the menu that we have available on the OnePCR device that I was just talking about, and the one that I showed you a small demo of. It has probably one of the most comprehensive menus that you can imagine on a point-of-care device, ranging from oncology, reproductive, respiratory, vector, blood-borne infections, etc. So with that, I request you all to visit us at booth F60, Genes to Me, and we'll be happy to show you this device live in action and, in fact, much more of our portfolio. Thank you so much for your time.